Welcome back to the build series. In today's video we're going to be getting into the electronics. Fair warning, I am a mechanical, not an electrical engineer, so there's probably a smarter and safer way of doing a lot of this, but what I did is working fine so far. So here is a very crude wiring diagram for all of the mini electrical components. We have 120 volt AC power coming in from a wall socket with a fuse and a switch in between. I then have these 3 power blocks to split the hot, neutral, and ground connections to the various components that need AC power. This will supply power to the laser power supply, the router power supply, the air assist and water pump for the laser, and the 12 and 24 volt DC power supplies. The 24 volts will power the 6 stepper motors that are controlled by 4 stepper drivers. The 12 volts will power the fans for the water cooling system, and of course the brain of the machine, an arduino Mega coupled with a Ramps 1.4 shield. This is a common controller for many 3D printers and will work for the CNC and laser as well, with a few modifications to the code. More on that later. The Arduino will plug into the stepper drivers, end stops, and the extruder components, as well as the control switch for the laser. These components will be housed in one of the drawers that I built into the stand, so I started by laying out and screwing everything to the bottom. In some instances, I had to use this method of creating a template with blue tape to mark the hole locations. I didn't film any of it because it was super tedious and boring, but I wired up all the connections according to the wiring diagram I made and installed the drawer. I then routed out a hole in the side of the stand to house the main switch and AC plug. With everything connected, I turned my attention to wire management. I bought a cable chain for the X and Y gantries and just installed them with some leftover materials. I was really just making this up as I went along, and I was lucky to find these long channels in my garage that work perfectly as cable troughs. I also had to mount the 2 end stops, and unfortunately these had 3mm instead of 5mm mounting holes, so I couldn't fasten into the T-slots and I had to tap and drill some mounting holes for it. So with all of the hardware done for now, let's take a look at the firmware that we will be using to run the machine. I'm using Marlin, which is a popular open source firmware for 3D printers, and has all of the necessary functionality to operate every aspect of the MODUMAKER. I've downloaded the code and opened it in the Arduino IDE. We are going to be primarily focused on this configuration header file, which is where we will be making all of the necessary changes. The first thing we need to do is find our temperature sensor in this list and change sensor 0, or the extruder sensor, to the corresponding number, in this case 5. We need to do the same thing for our stepper drivers. I'm using a TB6600, so I'll change that for the X, Y, Z, and E0 drivers. And don't forget to uncomment these lines so that the code is actually recognized. I'm also going to be lowering the maximum feed rate for my Z-axis because it's so heavy. This was determined based on the estimated build platform weight, as well as the equation used in episode 1 of this series. I'm also lowering the accelerations and adding an S-curve to it, because the gantries have so much mass to them and it takes a lot of force to get them moving. This should mitigate the risk of the motor skipping steps when it's getting up to speed. I also realized that because of how I wired the motors, I needed to invert their directions. With the code uploaded to the Arduino, I powered it on and tested it out. I was apparently very pleased to see the X gantry moving, even though the camera can't see it. The Y motors, however, were giving me issues, and I eventually realized that there was a mistake in the wiring. Because the two Y motors need to turn in the opposite direction, I needed to wire them into the same driver but with opposite polarities. This is done by switching the black and blue and red and green wires like so. And with that done, the motors worked perfectly. The only thing left to do was to calculate the correct steps per millimeter, which is done with this equation. And there's a million more resources explaining how to do this, so I won't bore you with it. With everything allegedly working properly, it was finally time to test it out. So I put a temporary spoil board onto the bed, uploaded some G-code, and let it do its thing. I was really impressed with how this thing worked, but there's still a lot to be done, and a lot to improve upon with the CNC especially. That'll be the topic of the next video, so I'll go ahead and leave it for that one. Thanks for watching.